So today we're going to look at parabolas. So parabolas are the graph for quadratic functions. Okay, so a quadratic function is a function where you have a degree 2. All right, so let's say if we've seen quadratic functions before. So where I have, let's say, y equals x squared plus 5x minus 1, right? Because the degree here, the highest degree is 2, right? That's the highest degree that we have. We call this function quadratic. And the graph of that function is going to have a parabola shape. Okay, a parabola shape is a shape. It's either like a U, where you have a smooth opening up curve, or it could be like a U upside down, okay, where it's going to open down like this. And the reason we have the arrows is that because it keeps going down or it keeps going up. It doesn't stop right there. Okay, so quadratic, degree 2. Highest degree is degree 2. It's called quadratic function, and the shape of the graph is called a parabola. Okay, the parabola is a symmetrical shape. Okay, so basically if I actually take this and I cut it in half, right, fold them on top of each other, they're going to fold symmetrically like a butterfly. Okay, they're going to be symmetrical. So it's a symmetrical shape. Okay, so does that make sense? When would I have a parabola shape? So it has to have a degree 2, that's the highest degree. Okay, and then the shape would be a parabola shape, and it would either open up or down. Are you guys okay with these terminologies so far? So the shapes that we have looked at before, they're the linear shape, yes? Before we looked at lines in the previous units, right? We just looked at straight lines, either going down or going up, right? Or horizontal lines. And they had the equation of y equals something x, so it could be like 2x plus 5, yeah? Where the degree here was 1, degree 1. In the case of quadratic, the degree is going to be 2. That's the difference between the two. Are we okay with this? All right. So in this lesson, we're going to look at the direction of opening of a parabola. So when does it open down and when does it open up? We're going to look at the values for the maximum and minimum. We're going to look at the values of x and y intercept, and then the coordinates of the vertex, and stating the equation of the axis of symmetry. Bless you. It's okay. We're all in the same boat. So, if you look at this parabola right here, you say that this parabola opens up or down? It opens up. Yes? So this parabola opens up. And this parabola opens down. When a parabola opens up, does it have a minimum or a maximum value? So it goes down and then goes back up. Do we call this a minimum or do we call it a maximum? Minimum, right? So when a parabola opens up, it's going to have a minimum value, all right? And it's located at the bottom of the parabola. Okay, so we call this a minimum. So it's like, going downhill and then going back up. So you have your minimum of the valley. On the other hand, when a parabola opens down, it's going to have a maximum value, right? So you have the hill. And this is going to be your maximum value. Let's look at this example. Is this parabola opening down? It's opening down, right? So does it have a max or a min? Now, when I ask you what is the value of the maximum or the minimum, in this case it's going to be a maximum, you're going to look at the y value of this point. So this point right here, where is your y value of this point? 2. So the y value is 2. So therefore your maximum is at y equals 2. Does that make sense? Because that's a maximum y value that you're ever going to have for this graph. Any other y value is below 2. Yes? So if I look at this y value, it's going to be at 0. If I look at this y value, it's going to be at negative 2. So if I'm going to be looking at this, it's going to be negative 4. This is going to be 1. So any y value after that, they're below the maximum of 2. Does that make sense? Okay. So let's look at this question. Let's start with this graph. Max or min? Min. And at what y value? So this is 1, 2, 3. So y equals to 4. You see how I write y equals to? For B, for this one, do I have a max or a min? Max at what value? At y equal negative 3. Max or min for C? At y equals 2. D, a minimum at at y equals negative 4. Okay? Are we okay with this? Good. Now, that point, that's either your maximum point or your minimum point, it's called the vertex. Okay, so this is where your graph is going to switch from going up to going down or from going down to going up. Okay, so that's your turning point, we call it. Okay, so it's called the vertex. The vertex is a point where you're going to have to include in that point the x and the y value of the vertex. Okay? So if I look at this point right here, which is my vertex, my x value is 1, and my y value is 2. So therefore, my vertex is a point, okay? So it must have an x and a y value. The x value is 1, and the y value is 2. So the vertex for this parabola is 1, 2. Are we okay with this? So if I look at this, it's asking me what are the coordinates of the vertex of the parabola given below. So what's your vertex? 7. So the vertex is right here at the bottom, right? So it's at 7. And then the y value is at -4. So the vertex is 7, -4. You have to write it in brackets because it's a point, and point has to be written in brackets with the x value first, the y value second. Are we good with that? All right. So the equation of the axis of symmetry is the equation of the vertical line that divides the parabola exactly in half vertically up and down. So if I want to graph a line, vertical means up, down, cuts my graph in half, where do I graph it? So this is your parabola. Yes? If you're going to draw a line that cuts this parabola in half, a line vertically, where do you draw it? In the middle, that has to pass through what point? It passes through the vertex. So if I'm going to graph a line that cuts this in half, it's going to pass through the vertex. Okay? We call this line, it's an imaginary line, we call it the axis of symmetry. Okay? So this is called the axis of symmetry. You'll probably see me referring to it as AOS. So remember that this line always passes through the vertex vertically. So if I'm going to write an equation for it, it's going to be, because it's a vertical line, I'm going to go back here. A vertical line has an equation of x equals to something, yes? So what does it pass through? What value of x does it pass through here? X equals 7, yes? So if you look here, that point right here is 7, right? My vertex here is 7, -4, yes? So my axis of symmetry is x equals 7. So when the question is asking you to write an equation of the axis of symmetry, you're going to write x equals and the value of that passes, of x that it passes through. Okay, now question for you guys. I'm going to go back to what we learned earlier. Do I have a min or a max here? Min. What's the minimum value? -4, okay? So the minimum is y equal -4. Yes? That's what we learned earlier in the lesson today. Now, do you see any relationship between the axis of symmetry and the minimum and the vertex? The axis of symmetry represents what part of the vertex? The x part. The minimum value represents what part of the vertex? The y. right? So these two, they make this, the axis of symmetry, makes the x part of the vertex, and the minimum value makes the y part of the vertex. Are you okay with that? Notation is very important. You see that I'm writing x equals the value, y equals the value. I am looking for this notation when I'm marking. It's like writing a paragraph, right? Where you have to start with, or writing a sentence where you have to start with a capital, and then you have to end it with a period and whatever, right? So that's very important in math. So let's look at this. See here. So they're asking you for the vertex. What's your vertex here? What's the vertex? I'm asking for the vertex. What is the vertex? I'm asking for the vertex. The vertex is the point. 1, 2. So when I'm asking you for the vertex, I'm asking for the point. What is your axis of symmetry? Is that what I would write? X equals 1. Because if I'm going to draw the axis of symmetry, it's going to be right here. Yeah? And it's going to pass through x equals 1. Let's look at D. What is your vertex? So your vertex is at 7. So vertex is a point, which is 7, -4. And what is your axis of symmetry? Yeah. Because remember, again, I'm going to have to draw a line, vertical line, to cut it in half. Are we good with that? Do you guys have any questions about this so far? Now I'm going to look at the x-intercepts and at the y-intercepts. Okay? So the x-intercepts, as you might have guessed, is when the graph intersects your x-axis. Okay? So where is this graph intersecting the x-axis? How many spots is it intersecting? Twice, right? It's intersecting twice, so it's intersecting right here and right here. Okay, so we call these the x-intercept, and then we write them as x equals -5 and x equals -1. Okay, so it's x equals -5 and x equals -1. How about the y-intercept? What does it mean? It's when the graph is intersecting which axis? The y-axis, right? And the graph is intersecting the y-axis one spot, and it will only intersect at one spot. Okay? And in this case, it's at y equals 5. So that is your y-intercept at y equals 5. For the y-intercept, yes. The x-intercept, it could intersect twice, one time, or it can never intersect sometimes. Okay? So if I have something that looks like this, how many times is it intersecting? The x-axis. It's intersecting twice. How about in this case? How many times is it intersecting? 1. Yeah? How about if I graph something like this? How many times will it intersect the x-axis? None. Okay? So when we're talking about the x-intercept, we always have 3 cases. Either it's going to intersect twice the x-axis, it's going to intersect the x-axis once, or it's never going to intersect the x-axis. Okay, we'll talk about scenarios when this happens. Okay, you need.
This one is some question is it? I just put it on the back of my.
Okay, I'm gonna have to give you unit 4. You just have. Are you gonna be in Mr. Jacoby's class now? Okay, I'll come back and give it to you. Okay, because I have to finish. Yeah. Are you guys okay with this? All right, so when we're talking about the x-intercept, we're talking at when is it intersecting the x-axis. Y-intercept is when it's intersecting the y-axis. So, the question here is asking you, what are the x-intercepts? Another word that they use for x-intercepts is zeros. Okay, so if they ask you for what are the zeros, this is another word for the x-intercept. Make sure that you know that. So what are the x-intercepts for parabola C and D? So can you tell me what the x-intercepts are for C? And is that how I write it? 0 and 2? What do I write? X equals 0 and x equals 2. Okay? So when I'm talking about the x-intercept, I have to include the equation, which is, or the x equals 2. This is my notation. How about for D? What are my x-intercepts? Five, yeah. So this is your x-intercept for D. Okay? Now, why didn't they ask me for the x-intercepts for A? There is no x-intercepts. You see how it's opening upward and it's above, right? It's never intersecting that x-axis. Are we okay with that? All right. What? Which one? A? This A? Is it going to ever touch this axis right here? No, because it's opening up and it's going to keep going up. Right? If it was going down, then yes, I can extend it and see where it's going to end. So if I had something like this, and they asked me to find the x-intercept, yes, I can kind of like estimate by extending it. But this is, no matter how much I extend, it's never going to touch the x-axis. Now, they're asking you for the y-intercept for A and C. Yeah. So what would be your y-intercept for A? at y equals 4. So the y-intercept right here. In this case, the y-intercept is happening to be at your vertex, right? It doesn't always happen, but in this case it is. So the y-intercept is at y equals 4. Okay, how about for C? Where's your y-intercept? That's what you think too? Yes. It's happening that the y-intercept is right here as well, right? Because that point is where it's intersecting both the y-axis and the x-axis. So in this case, the y-intercept is at y equals 0. Now, why they didn't ask me to find the y-intercept for D? There's one, right? There's one, but it's going to be way up there, right? That we have to be able to extend. We won't be able to find it right now from this graph, okay? There will be one, though. Are you guys okay with this? Is there any more at the bottom of this? Okay, so for each question, you're going to have to state the direction of opening, the maximum or minimum value. Okay, you're going to have to say maximum at this. Minimum at this. I want to see these words. You're going to have to, okay, so in this case, they're asking you to say, is it a max or a min? So this one, it's going to ask you, is it a max or a min? Okay. In this case, you're going to have to include the value. So you're going to have to say y equals to whatever the answer is. Okay. What are the coordinates of the vertex? And equation of the axis of symmetry. And then you're going to have to include the x and or y-intercept if shown in graph. Okay. So you're going to have to answer all these questions for A, B, and C. Okay? You can, if you want, right next to the graph, you can write I opens whatever. Okay? You can write max or min, I don't know. You're going to have to answer this, okay? So you can answer it next to each graph. All right? This is where the key question for today's lesson.